Hello, my name is Soriano from Robotnik Automation. We are a mobile robot manufacture company, and inside the fastest project, we are responsible for providing the unmanned ground vehicles, the UGVs, and also integrating different sensors on these vehicles, and also for developing some high-level functionalities like the autonomous navigation system and the 3D map algorithm. First of all, why we want to use UGVs in an emergency situations. Here I wrote some examples. The preliminary access to the scenarios, I think, is one of the most important things to have an initial detection and identification of a dangerous situation, and at the same time avoiding any human risk. But of course, the UGVs can carry several sensors at once and can use them to perform a remote perception of the environment, while first responders are monitoring the operation from a safe place. The other question is that what are the requirements for using this technology in emergency situations? For sure, UGVs should be easy to manage, should be also intuitive, reliable, flexible, and probably one of the most requested things. Non-technical knowledge should be required to use them, right? And this is what we are trying to achieve during this faster project. Inside the faster architecture, the UGVs are located at the edge level, and all the information collected by the sensors are sent to the fog level through the secure communication layer. This data goes to different interfaces. The COP, that is the Common Global Interface for all the faster technologies, and the ground station server. This ground station server has been added to the architecture to offer a real-time data feedback from the UGVs, and at the same time to control and trigger some events or functionalities like starting the 3D mapping module or create some missions for the autonomous navigation and these kind of things. These are the two UGVs developed by Robotnik for faster project, the Summit XL and the RV car. Both platforms form part of our product portfolio right now. Not at the beginning of the project, but not yet, right now, yes. Both have been sensorized, taking into account the requirements from the first responders and also the requirements from the pilots of the project. Let's see more in details the features of the Summit XL. This UGV is smaller than the RV car, and it has a payload of 65 kilograms. It has a differential configuration with 4 traction wheels with 500 watts of power. And the Summit has been designed and built totally by Robotnik from the scratch. So it's like our own unique model, let's say. These are the sensors that have been integrated into the Summit XL, and a stereo camera that we use for creating the 3D map of the environment, a 3D LiDAR to scan the surroundings of the robot, a thermal camera to identify abrupt changes of temperature or detecting hot objects or animals, humans, whatever. RGB camera with a pan tilt mechanism that allows to move and focus the camera to any interesting direction. And finally, a GPS device to receive the global position of the robot and manage the autonomous navigation. For controlling the robot, the Summit XL, we use a PlayStation 4 pad. There is mainly two ways to control remotely the Summit. You can connect directly the PS4 pad to the robot via Bluetooth, and this allows a range of teleoperation around 10 meters, more or less. And the other option is to connect the PS4 to the ground station server, having a long range coverage. Do it that works with 4G network communication, so there is no limits of range for this communication. Let's see one video, one video of Summit XL. This is the platform. As you can see, it has a thermal camera, 3D laser, RGB camera, and a stereo camera, and also the GPS device. Here we are looking at the interface that it's in the ground server, station server, where we can send directly to the robot some coordinates in GPS format, and the robot can move autonomously, and at the same time it's providing the video feedback from the cameras to the interface while it's autonomous navigating through the environment. Of course, the cameras can be controlled remotely as the entire platform. And now we are defining some autonomous mission where the robot should reach some navigation points that we have defined in the interface. And of course, we also offer the television module inside the interface to control remotely the vehicle. We have different controls. One is for the entire platform to move the robot around, but we have also the remote control of the thermal camera to focus on any direction. We can control also the zoom that we can do in the camera. Yeah, and I guess this is more or less what we can do with the Summit. We can visualize also the thermal camera here. We have there 2D map of the environment. You can see the measures of the 3D LiDAR. And some information regarding the battery and the velocity that the robot it's moving. Let's check another video. This is from Madrid, the Madrid mini pilot that we did. In this case, we use the Summit XL to explore the area surroundings of the building, and we were able to identify one person that was in the middle of the ground with the thermal camera. There you can see the emergency team helping the person. Okay, and then I have another video about the pilot from the pilot of Kajani in Finland, where the Summit was used to get into the building. As you can see, there were some kind of narrow corridor, and we use the Summit XL to get into building, checking at the same time the thermal camera image and the RGB camera image. Exactly. And also we were testing there the 3D map operation. In this case, it was done with the LiDAR, and we create a 3D model of the building, where the first responders could test how was the situation before to get into physically into the building. I have another example of the 3D mapping operation. In this case, it was done outdoors in the street. We were teleoperating the robot. Here in the interface you can see we are starting the 3D mapping module, and here you can see the robot moving. It's a little bit speed up. The video has been speed up just a little bit, and in the right side you can see how the robot is building the 3D map, how is creating this 3D map with colors and with the textures of the environment. And then you will see the final results of the 3D map here. This is the other strategy that we are using. One is getting the data from the LiDAR sensor, and the other one is this one. It's doing the map from the images that we are collecting from the stereo camera. Okay, I think that's more or less all about the Summit XL. Let's move on to the RV car. In case of the RV car vehicle, we started to work from an electric vehicle that was already in the market. This vehicle is like a car that can be driven by a person. Of course, we made some hardware modifications in order to automate the direction, the brake, the acceleration of the vehicle, and we add some extra batteries to feed from one side the vehicle, and from the other side the sensors and the control box that we are using to automate everything. It has an Ackerman configuration in this case, and can carry 2 people plus 200 more or less kilograms. So it's quite bigger than the Summit. These are the sensors that we have integrated. We have 3D front laser sensors for obstacle detection in front of the robot, and a stereo camera for creating the 3D map of the environment like in Summit XL. We have 3D LiDAR also for detecting the surroundings of the robot. A thermal camera that in this case has been mounted in a crane. We will see in detail in the next slide. And a powerful lights for working at night, and of course the GPS device for the global localization of the vehicle. As I was saying, the crane is this one. We built it from scratch. With this crane, the camera can reach 3 meters of altitude, and it has also a pan tilt structure where you can move the camera in any direction. For teleoperating this vehicle is different than this in the Summit XL. We have in this case a secure pad. This pad is connected to the vehicle by radio and has a maximum range of around 1 kilometer, more or less. The main difference is that this secure pad has an emergency button, so in case that something goes wrong or something is unsecure, you can just press the button and everything will stop, and the entire vehicle will be stopped. Let's check one video about the RV car, how we think that it can helps in emergency situations. You can see here how is the size. We think that probably would be able to reach the affected area driving the robot manually, as you are seeing. I will move a little bit. Okay. So let's say that we arrive to a secure control near to the affected area. One person can get out from the vehicle and the other one can keep driving to be closer to the affected area, like that. And then when it arrives, it gets out from the vehicle and use the crane to observe from above with the thermal camera what is happening around. If we can identify something with the camera or detecting some object that can be interesting for something, and then we can use the interface to send the robot again to the secure control point autonomously. Here we are at the same time while the robot is moving, we are seeing the camera object identification, where we will see some object description here when any object is identified, like any other cars or people or something like that. Here on top, on the right top square, we can see the trajectory that the robot will do autonomously, and on the bottom we can see the thermal camera streaming in real time. So the robot, when it's moving autonomously, the lights are blinking all the time, just to show that it's in autonomous mode. And as you can see, it's following the different points of the trajectory. Here you can see the objects that have been identified, like other cars, by the camera. And finally it reached the control point. So then another option is to transport supplies, people or tools again from the secure control point to the affected area, like right now. You can see one person is in the car, but the car is still moving autonomously, and it goes to the affected area, yeah, autonomously. So it's following the trajectory, and then finally it arrives to the affected area. From the perspective of the driver, to see how it feels This is another example of an autonomous navigation. We have defined a square of four, defined by the 4 points, as you can see here. And yeah, we are inside the vehicle while it is moving autonomously. Okay, I think that is more or less is clear. The idea behind these autonomous ground vehicles. I hope you enjoyed the presentation, and it was really nice to have this opportunity to describe our technology in this context. Thank you very much. Have a nice day.